Hello student, good morning. I am Dr.A.K, Professor of Chemistry. Today I am going to discuss effect of concentration change. Last class I have discussed, but little more I have to discuss in change in concentration. Okay, I was discussing actually factors affecting equilibria. In that I have discussed effect of concentration change. Now little more I want to discuss in this respect, and after that I will discuss effect of temperature, effect of pressure, and effect of inert gas. Also I will discuss effect of catalyst. Okay, these are the very important and asked in examination. Then effect of concentration, in that little more I want to tell you. It is interesting also, and this is experimental. Okay, effect of concentration and experiment. That is also, it is a question is asked because it is interesting, and this is the proof. This is the proof that about the, you can say, change in concentration, how it affects you can say chemical equilibrium constant. You can understand by this also. Okay, by change in concentration, how it affect the Kc value. By experiment also you can understand. Okay, in medical particularly this question is asked, medical IIT also, and in general for 11th 12th also, particularly 11th question is asked. Then here just try to understand this can be this experiment can be demonstrated by the ferric ion Fe3 plus thiocyanate SCN. Okay, SCN thiocyanide. If you can say in ferrous, not in ferrous, ferric, in ferric you can say salt. You can take any ferric salt like FeCl3 also you can say. FeCl2 is ferrous, FeCl3 is ferric. Anyhow, you are interested in ferric, means 3 plus. Ferrous is 2 plus, don't forget. Then suppose ferric ion reacts with thiocyanate, means SCN 1 minus. Then it will give the product FeSCN, means ferrous thiocyanate 2 plus. It will give the product 2 plus, means Fe3 plus now became Fe2 plus, because SCN is 1 negative, 1 minus, then obviously 3 plus. If you will add to 1 minus, then 1 plus will be neutralized, then 2 plus will remain. But here you have to understand one thing interesting, that ferric ion color is yellow. Its color is yellow, and thiocyanate color is colorless, no color. But if you will mix, you can say a few drops of thiocyanate in ferric, then you will get deep red color of ferrous thiocyanate. You will get ferrous thiocyanate, you will get deep red color, means this is the product after the reaction between ferric ion plus thiocyanate. It gives a deep red color. This is the product. Then what will be the Kc for this reaction? Then easily you can write like what you have written. I have told same way. Product concentration of product divided by concentration of reactants. Means FeSCN 2 plus aqueous divided by Fe3 plus aqueous into thiocyanate aqueous. Means molar concentration of ferrous thiocyanate aqueous divided by molar concentration of ferric ion into molar concentration of thiocyanate ion. This is actually ionic equilibria. This is called ionic equilibria. Why it is ionic equilibria? Because here we are mentioning all are in the ion form. Ferric ion, thiocyanate ion, both are ion, and product what is forming, that is also ion. Then this is also called ionic equilibria. Then now listen, a reddish color appears, a reddish deep red color appears on adding 2 drops of 0.002 m potassium thiocyanate. If you will add potassium thiocyanate in a ferric solution, okay, then you can tell ferric means you can tell ferric nitrate also, iron nitrate you can tell, iron third nitrate. Iron third nitrate, suppose that is a 0.2 m, suppose, and you have added in that potassium thiocyanate you have added 0.002 m. Then this both will react, and due to the formation of ferrous thiocyanate, its color will change. That is the deep red color. Now, what is the interesting here? That now deep color is there. Deep color FeSCN 2 plus. But now, if you will remove from this FeSCN, if you will remove Fe, then this color will change. Now, because FeSCN is there, now from this Fe if you will remove, quantity of Fe you are removing, then now it will shift towards the left, means towards reactant. Okay, because iron is not there, then color will change. Then color, what was the deep red, now that red color, deep red color will slowly its intensity will decrease because Fe you are removing. Because in that Fe and SCN reacted, but now Fe is less. That's why that you are removing Fe, then their color, the deep red color will change. It will become less intense. Okay, less deep red color, less red color you will get. And also, if you will remove SCN thiocyanate, potassium thiocyanate you added and thiocyanate, then again this product will not form, or because it is less, hence again it will give deep red you will not get. You will get red, less intense you will get. Means if both are less, ferric and thiocyanate ion, if both are less, then product form will be also less. Means red will be not deep red. Okay. Then this how you will do all the things. Then actually I told you how equilibrium is changing. When ferrous and thiocyanate, if both you will add, then product will form. If both quantities are more, then a more intense deep color you will get. If from the product side, if you will remove anyone, either iron or thiocyanate, then their color will change, anyone, because now equilibrium will shift. Equilibrium will shift towards a reactant side. Okay, this is very interesting. Okay, then this equilibrium means of this reaction, ferric plus thiocyanate and ferrous thiocyanate, it is forming this equilibrium can be shifted in either forward or reverse direction depending on our choice of adding a reactant or a product. Okay, we can change the, you can say this thing, we can shift the equilibrium either towards either reverse direction or forward direction according to our choice, but with use of suitable reagent. The equilibrium can be shifted in the opposite direction by adding reagents that remove ferric ion. Okay, that remove ferric ion or SCN ions. For example, oxalic acid H2C2O4, that is called oxalic acid, 2 hydrogen is there. Also you can tell COOH whole 2, COOH whole 2, or molecular formula is H2C2O4. Okay, then for example I am telling you oxalic acid reacts with ferric ions to form the stable complex ion FeC2O4 3 minus. Okay, it will form, means ferric you are removing. Oxalic acid will react with ferric ion and it will form a complex, a stable complex FeC2O4 whole 3, and complex will have 3 negative charge, FeC2O4 whole 3, but it will be ion, this is the complex ion having 3 negative, thus decreasing the concentration of free Fe3 plus ion. Now in reaction or in equilibrium you can tell 3 ion is decreasing because oxalic acid has taken that ferric ion. Okay, thus decreasing the concentration of free ferric ion. In accordance with the Leach-Ariel principle, the concentration stress of removal of Fe3 plus is relieved by dissociation of FeSCN2 plus. What was that? Now this will be disturbed. It will come towards, you can say, left, means towards reactant. Okay. Then what will happen? Because a ferrous ion from the product, you are after adding oxalic acid, it is because Fe is removing, that's why again it will shift toward the reactant, mean equilibrium shifted, because the concentration of FeSCN decreases, the intensity of red color decreases. Okay, now also you can understand other example. Adding of aqueous HgCl2 mercurous chloride. Actually Hg exists in 2 forms just like iron, ferrous and ferric. Ferrous means 2 plus, ferric means 3 plus. Like that way mercury, Hg also exists in 2 forms, mercurous and mercuric. More is ic, always more is ic. Then Hg3 plus is mercuric and Hg2 plus is mercurous. Always more plus means ic, keep in mind. Now here you understand addition of HgCl2 also decreases red color. How and why? Because the Hg2 plus react with SCN, thiocyanate ions, to form a stable complex ion, that is the HgSCN whole 4. It will form a complex ion having 2 negative. What is the complex ion? Then HgSCN whole 4 and charge is 2 negative. The removal of free SCN removal of free SCN thiocyanate shifts the equilibrium in towards the from the right to left. Shift the equilibrium from right to left, from product to reactant side, to replenish thiocyanate ions, because thiocyanate is decreasing, hence it will go back towards reactant. Addition of potassium thiocyanate, addition of actually in this way also color will decrease, because complex disturbed thiocyanate is taken by, you can say, mercurous chloride. It has taken thiocyanate and formed the new complex. I told you HgSCN whole 4, and charge is 2, ion has 2 negative charge. Then this also color will be less intense red color, because complex has shifted towards backward, means reactant side. Okay. And addition of potassium thiocyanate, if you add potassium thiocyanate, on the other hand, increases the color intensity of the solution, means as it shifts the equilibrium to the right, means potassium thiocyanate if you will add, then it will shift to the equilibrium, will shift to the right, and if mercurous chloride you will add, then it will shift towards the left. Correct? And this also, oxalic acid also, if you will add, it will shift to the left only, means towards reactant. This is very, very interesting. And see how equilibrium is changing, how they are maintaining the equilibrium according to the change. Then this is actually from the both angle, two angles, from the inorganic chemistry also, this color and other things they are asking in inorganic chemistry. Then here actually you are understanding shifting of equilibrium, but here color, what is the color of this ferrous thiocyanate, now you have understood, and color of ferrous also you understood, it is yellow color, ferric is yellow color. Okay. Then this I have told about the effect of concentration on equilibria. Now I am going to tell effect of pressure change on equilibria. Okay. Then here now you can understand a pressure change obtained by changing the volume can affect the yield of products in case of gaseous reaction, where the total number of moles of gaseous reactants and total number of moles of gaseous products are different. Both number of moles of reactant and number of moles of product must be different, only then it will apply. Okay. And here best example I have already given, N2 plus 3H2, N2 1 mole, 3H2, H2 is 3 mole, total 4 mole reactant, and it is giving 2NH3, means 2 mole ammonia. Then see, reactant are 4 mole, products are 2 mole. Then here in this reaction it will apply, pressure will apply, because number of moles of reactant and number of moles of products are different. Where both are different, only their effect of pressure will be there. Otherwise, if both are equal, then no effect of pressure. And means reactant and products must be in gaseous state. That is the condition. Reactant and products must be in gaseous state. Then here already I have told you in the beginning only, that here see, ammonia volume is only 2 mole. Ammonia is only 2 mole. Product is only 2 mole. Reactants are 4 mole. 1 mole nitrogen and 3 mole hydrogen. Then here volume is changing. Volume decreased. Then volume decreased. When will volume decreased? When pressure will be more. When pressure will be high, only then volume will decrease. Keep in mind. And reverse case also, when pressure is high, then according to Boyle's law, volume will be less. If pressure is less, then volume will be more. Reverse case also you keep in mind. Then here I have given a very good example of, you can say, change in pressure. Other example again you can understand. Okay, I have told you that if there is no change in number of moles of reactant products when both are same, then that time it will not work. There will be no effect of pressure independent of pressure. Equilibrium will be independent of pressure. Okay, but here everywhere LECT principle is, they are obeying the LECT principle. Okay, and I have told you in heterogeneous equilibrium. Now consider heterogeneous. In a heterogeneous equilibrium, the effect of pressure change on solids and liquids can be ignored. Here again I am telling you, in heterogeneous equilibrium, heterogeneous means you know that phase will be different. In heterogeneous equilibrium, the effect of a pressure change on solids and liquids can be ignored because the volume that and concentration, that is the volume and concentration of a solution or liquid is nearly independent of pressure. Solid, how much there will be change in pressure in solid or liquid? Main change will be with the gas, not a major change. In solid, no change at all. Liquid, negligible. But main change will be in the gaseous state. Hence, for the solid, in case of solid and liquid, there will be no effect of pressure, independent of pressure. Okay, now I am giving another example. Carbon monoxide plus hydrogen, CO plus 3H2, 1 mole CO, 3 mole H2. Then it is giving CH4 plus H2O. 1 mole CH4 plus 1 mole H2O. All are in gaseous form. Carbon monoxide is in gaseous form. Hydrogen gas is in gaseous form. Methane is in gaseous form. H2O is in gaseous form. Then in this reaction you can see 1 mole CO and 3 mole H2, total 4 mole. And product is how much? 1 mole CH4, 1 mole H2O, means only 2 mole. Then here change in pressure will apply and it will affect equilibrium of this reaction, because number of moles of reactant and number of moles of product are different. Okay, here 4 mole of gaseous reactants, CO, 1 CO plus 3 H2 becomes 2 mole of gaseous product, 1 mole methane, 1 mole H2O. Suppose equilibrium mixture for this reaction kept in a cylinder fitted with a piston at constant temperature and is compressed to 1/2 of the volume. It is compressed, means you are applying pressure. Then total pressure will be doubled. Okay, you have decreased half, volume made half. Then pressure will be doubled according to the PV is equal to constant. Okay, PV is equal to constant. Okay, you know Boyle's law. It will be doubled. Okay, this is the important thing. The partial pressure and therefore concentration of reactant and products have changed, and the mixture is no longer at equilibrium because you have applied the pressure. Then obviously this will change, equilibrium will change. The direction in which the reaction goes to re-establish equilibrium can be predicted by applying the LECT principle. Since pressure has doubled, the equilibrium now shifts in the forward direction, means less volume is there CH4NH2 only 2 mole. Then by following the Le-Chatelier principle, concept, pressure has doubled, the equilibrium now shifts in the forward direction, a direction in which the number of moles of gas or pressure decreases, because pressure here are increasing, then it will change in that direction where pressure decreases. Okay, we know pressure is proportional to moles of the gas. Okay, this can also be understood by using reaction quotient. By that way also you can understand. Wherever equilibrium will disturbed, that time Q will come, QC. That time only its role will come. If it is equilibrium is maintained, then Kc role will come. If equilibrium is going to be disturbed, then QC role will come. Okay, then this can be understood by the reaction quotient also. Then here QC is equal to what? Then product divided by concentration of products divided by concentration of reactant. In this way we can write Q. Then molar concentration. Then here if we put the value of molar concentration, then you will find that upside is less, product is less, and reactant is more. Then obviously Q will be less. If products are means methane and H2O, that is there is a number is only 2 and down is more, then obviously Q value will be less. Okay, because if down denominator it is value is more, then Q will be less. It means Kc will be more. If Kc is more, then change will take place. Equilibrium will shift towards forward, means towards product. Okay, then that way how they are changing or maintaining the equilibrium, shifting the equilibrium, that I have told you. Okay, then these two equations where volume is changing, I told you N2 plus 3S2, 2NH3. Here it will apply the pressure. Change in pressure will change the equilibrium. Here pressure has a role. And second example, just now I told you that CO plus 3H2, it is giving CH4 plus H2O. Here also it will apply. In this case, Q is less than Kc. Okay, by following the QC expression also you can understand. In reaction carbon plus CO2. Now take another example. Third example. In reaction carbon, which is a solid, plus CO2 means carbon dioxide, it will form carbon monoxide, 2CO gas. Okay, this is also in equilibrium. Carbon solid plus CO2, it gives 2 mole of CO. Then both are now, suppose it is in equilibrium. Then here you can see 1 mole carbon, 1 mole CO2. Total number of moles is 2 and product is also 2 CO gas. Okay. When pressure is increased, the reaction goes in the reverse direction because the number of moles of gas increases in the forward direction. Here you have to understand this reaction. I told you, third example, carbon plus CO2, carbon solid, carbon dioxide gas, and it is in the equilibrium, 2CO. When pressure is increased, if you will apply, then what will happen? Is increased, the reaction goes in the reverse direction because the number of moles of gas increases in the forward direction. Okay, because pressure you will apply, then here solid is there, carbon solid, it has no role, no role. Then only carbon dioxide is there, only one, and this is a product is 2 mole. A reactant is only 1 mole because carbon is solid, it will not apply. Then if you will apply, then it will go in a reverse way. Okay, volume will decrease, then decrease means reverse way. Okay, means it will form more carbon dioxide. Understood? Here carbon is solid, that's why it has you can't count number of moles. Then carbon dioxide apply the pressure on this reaction, then reaction will shift toward the backward in a reverse way. This I told about the effect of temperature. Effect of pressure I have told you. Now I told you two things also I will tell, that is the effect of additional reactant like inert gas. If you will add inert gas, then what will happen? Effect of inert gas on equilibrium. Here in one line you should understand, because gas is inert and you are adding in the equilibrium mixture, it will not react neither with reactant nor with product. It will not react with anybody. Okay, anything. That's why there will be no effect of inert gas on equilibrium. Okay, no effect. Inert gas has no effect on Kc, chemical equilibrium constant. If the volume is kept constant and an inert gas such as argon is added, which does not take part in the reaction, the equilibrium remains undisturbed. There will be no change in equilibrium. It is because the addition of an inert gas at constant volume is constant, does not change the partial pressure or the molar concentration of the substances involved in the reaction. The reaction quotient changes only if the gas is reactant. The reaction quotient, when Q, changes only if the added gas is a reactant or product involved in the reaction. Okay, but here it is inert gas, hence it will not take side of anybody, neither it will take side for reactant nor the product. Hence in a simple way you can tell that inert gas has no effect on equilibrium constant or equilibrium. Okay, now I am going to tell about the effect of temperature change. Effect of temperature change. Now here, effect of temperature change on equilibrium. Whenever an equilibrium is disturbed by a change in concentration, pressure or volume, the composition of the equilibrium mixture changes. Already you know, because the reaction quotient Q no longer equals to the equilibrium constant. Means both will be not, if Q will be equal to Kc only at equilibrium. Okay, when this will change, concentration, pressure will change, then only Q will change, otherwise it will not change. However, when a change in temperature occurs, the value of equilibrium constant, then the value of equilibrium constant Kc is changed. The temperature has a major role. Temperature and pressure, concentration 3, it has a major role. Okay, then now we understand in general the temperature dependence of the equilibrium constant depends on the sign of delta H. Here it is very conceptual. See, delta H, it depends upon the delta H. Suppose delta H is negative, means during the reaction heat is coming out, it is going out, and there if you will heat, you will apply, temperature you will increase, then what will happen? Unnecessarily you are applying, already heat is coming out and you are increasing the heat, temperature you are increasing, then what will happen? That it will have reverse effect. It is not positive, it is not helping. It is not helping to the reaction. That reaction, this type of reaction where delta H is negative, it is not helping to that. It will have adverse effect. It will have adverse effect. It will not help that reaction. Means production will be not more. It will have a reverse case. It will help only when delta H is positive. Means where heat is required. Where heat is required means endothermic. Delta H negative was exothermic. Already heat is coming out. And why you are giving the heat? It is useless. It will reverse. In that case, product will be less. It will not help to in the formation of product. Product will be less. But if where heat is required, there if you will give heat, then it is helpful. Means endothermic, in case of endothermic reaction, where heat is required, there it will help. Means more production will be there. Product will be more, because here in the case of endothermic, more product it will give. But in the case of exothermic, less product will give, because they don't want. This concept you give in mind. Okay. Where heat is required, there if you are temperature increasing, heat you are giving, that is helpful. More product. This you keep in mind. And where already heat is coming out, delta is negative, they don't want, then it will work in a reverse way. Production will be less. Product will be less. These things just you try to understand. I have briefed you. Okay. The equilibrium constant for an exothermic reaction means negative delta H decreases. The equilibrium constant for an exothermic reaction decreases as the temperature increases in a reverse way. Equilibrium constant value decreases as the temperature increases in the case of exothermic reaction. Second, just reverse way, the equilibrium constant for an endothermic reaction means positive delta H increases. Equilibrium constant increases, value of equilibrium constant increases as the temperature increases. Only these 2 points, only 1 point to keep in mind, other is a reverse. Okay. Temperature change affect the equilibrium constant and rate of reaction also. Here, till date I was telling the no role equilibrium constant, as in there, we were rate, they were not telling, equilibrium constant will not tell about the rate, but temperature, effect of temperature will change the rate of reaction also. If temperature will increase, the rate of reaction will increase, or if temperature will decrease, then rate of reaction will decrease. In chemical kinetics, rate of reaction you will study, there you will find all these things. Okay. Temperature change affect the equilibrium constant as well as rate of reaction. Don't forget. Okay. Production of ammonia. Now you can see. Actually, this Haber process is very, very important. Always, everywhere it is discussed. Whenever equilibrium chapter you are studying, equilibrium constant you are studying, that time always this example will come. It is very, very important. Okay, then here you can see production of ammonia according to the reaction N2 plus 3H2, it is giving 2NH3. Okay, it is in equilibrium. Delta H value is minus 92.38 kilojoule per mole. Its value also you remember, minus 92, minus exothermic reaction. Then you can understand reaction is exothermic, hence very high temperature is not required. Not required. Okay. Delta H is minus 92.38 kilojoule per mole. This is an exothermic process. According to LECT-105 principles, raising the temperature, if you will increase, then raising the temperature shifts the equilibrium to the left. Means product side not, reverse way, left side, reactant side it will go. Equilibrium will shift towards left, means into and decomposition will take place, not formation, decomposition of ammonia, and it will give nitrogen and hydrogen. See the effect. Unnecessarily, no, it is in this case, exothermic case not required. Otherwise, it will give, then decomposition will take place and product will break and it will give reactant. According to LECT-105 principles, raising the temperature shift the equilibrium to left and decreases the equilibrium concentration of ammonia. Okay, and this thing decreases the equilibrium concentration of ammonia, means ammonia production will be less. In other words, low temperature is favorable for high yield of ammonia, low temperature. Okay, but practical, already I told you this point in the beginning, but practically what has been seen, but practically very low temperature slow down the reaction, and thus a catalyst is used. If you will can say decrease the temperature very less, then it will affect the production also, because rate of reaction that will be slow. That's why a mild temperature around 500 Kelvin is required, because you have to increase the rate of production also, rate of reaction, but for the rate of reaction high temperature is required. And but according, because exothermic reaction is there, in that case it is telling no, less temperature. That's why that will become that compromise will be there, and then one mild temperature, that is not very high, not very less, around 500 Kelvin temperature is required, but pressure will be very high. Okay, then I have told you about the effect of temperature on equilibrium constant or on equilibria. Okay, and now one more experiment wise also you can understand it. How can you tell that experimentally also, just like what I told in the case of concentration, by color change you understood how it is equilibrium is shifting. Here also you can understand why these things 2NO2, nitrogen dioxide, NO2, it is a brown gas. Okay, brown gas. Effect of temperature on equilibrium can be demonstrated by taking NO2 gas. This is a brown gas. Keep in mind, for a general knowledge also, NO2 gas is brown. Always question is asked. Okay, NO2 gas, that is a brown in color, which dimerize into N2O4 gas. N2O4 gas is colorless, no color. NO2 will dimerize, means NO2, N2O4. It will become double. Molecule will become double, N2O4. Then 2NO2 will give N2O4, and it is again exothermic reaction, minus 57.2 kilojoule per mole, exothermic reaction. Then here also temperature has no role, not required. If the temperature will increase, the temperature, it will go shift, equilibrium will shift to the left direction. Now experimentally, just to see, it is interesting. Okay, NO2 gas, suppose actually NO2 gas is gas prepared by addition of copper turning and conc HNO3. This reaction also, it is a common reaction. Copper turning, just like a ribbon form. Copper turning and concentrated HNO3, if both will mix, then NO2 gas, brown NO2 gas comes out. Okay, this gas you can collect. NO gas is ready. Is collected in two test tube. In two test tube, you have taken this gas, NO2 gas. Okay, two test tube, because both test tube, both NO2 gas you will keep in two places. In two places means different temperature. One you will keep it less temperature, other you will keep in high temperature, and you will see the what happens. Okay, both gas have in the beginning they will have same temperature, atmospheric temperature, but one gas you can keep in low temperature, just where freezing mixture is there, in there you can keep one test tube where CO2 NO2 gas is there, and other gas you can keep in you can say you can keep in a vessel whose temperature is more. One you are keeping, two test tube is there, in both NO2 gases there. One you are keeping in the low temperature, means in freezing mixture, temperature will be low. Other you are keeping in high temperature vessel. Then now what will happen, that you have to understand. Then you can see here what you will find, that there will be color change at low temperature. At low temperature, where freezing mixture kept in the freezing mixture, at low temperature, the forward reaction of formation of N2O4 will preferred. Okay, it will convert to the N2O4. When temperature is low, then it was brown, it will turn to colorless. Colorless means N2O4 gas formed. Equilibrium changed towards forward direction, because now it will give, it was brown, now it is becoming colorless, means N2O4 is forming. Reactant is giving product. Reactant means equilibrium shifted to the forward direction. And when you will keep in the warm vessel, hot, then there you will find that now this color is changing. Original color is coming, means NO2, brown color is coming, means now equilibrium shifted towards left. Then see how equilibrium is shifting forward or backward. Okay, then by this experiment also you can understand. Okay, these things I have told you. Effect of temperature can also be seen in endothermic reaction. Now I told in the case of exothermic reaction, this 2NO2 was giving N2O4 and delta H was negative 57.2 kilojoule. Then you have seen how equilibrium is changing. Now in case of endothermic also you can understand. Effect of temperature can also be seen in an endothermic reaction, like cobalt, hydrated cobalt you can take, COH2O whole 6 hydrated. Okay, this is the complex ion, it has 3 plus. Cobalt hexa you can say cobalt hexahydrate, cobalt hexahydrate 6, COH2 whole 6, ion is 3 plus. Plus 4 Cl. Suppose chloride ion is there, this reaction is there, that complex ion is there, cobalt hexahydrate plus 4 Cl minus. Aqueous solution, it is giving after the reaction it will give cobalt tetrachloride complex, it will give cobalt tetrachloride complex, it has 2 negative, plus 6 molecules of water it is giving. Okay, then here cobalt H2O whole 6 means reactant is pink color. This color also you remember, pink color, it is very beautiful, you can see the color, pink color. Cobalt H2O whole 6 complex is pink color. In that chlorine 4 chloride ion, means chloride ion is balance equation I told you, chloride ion is reacting. Then what will happen? 4Cl is there and COH2O. Then in the place of H2O, Cl will come. Then it will form COCl4 plus 6H2O. Then Cl, chloride ion, is colorless gas. And now this product, it is forming COCl4 ion, complex ion COCl4 2 minus. That is the blue color. Then see how pink color is converting to blue color. Blue color due to the this. Now this reaction is in equilibrium. Okay, cobalt hexahydrate plus 4Cl. It is giving COCl4 ion 2 negative and 6H2O. Both are now equilibrium, means pink cobalt converted into the blue cobalt. Then now here see, this reaction is endothermic. Now what will happen? At room temperature, the equilibrium mixture is blue at room temperature. Okay, when cooled in a freezing mixture, suppose this you have kept in freezing mixture, reactant or complete things, blue color product was there. That product color, suppose you have kept in a freezing mixture, cold place. Then what you will think? The color of the mixture turns pink. What was in the beginning? Means it turned to the pink. Then room temperature and freezing temperature. Freezing temperature is less, low temperature. Then at high temperature, it was giving the product. Okay. At room temperature, the equilibrium mixture is blue. The room temperature is high in comparison to the freezing mixture. This is around the zero. Room temperature is 25 degree. Then at 25 degree, it is giving the product, means forward direction. But if we will keep in the freezing mixture where temperature is less, then it will give it, this equilibrium will shift to the left reactant side and it will give pink color. Okay, this I told about the effect of temperature. Okay, now last I am going to discuss, that is the effect of catalyst. A catalyst increases the rate of the chemical reaction by making available a new low energy pathway. This catalyst major role is in increasing the rate of reaction by changing the path where less temperature is required. This you keep in mind. Suppose already I have sent one diagram of activation energy. Okay, only for this purpose I have sent. Then here, so actually gaseous molecules, suppose two gaseous molecules are reacting, and like as for example like N2 and nitrogen and hydrogen, both are reacting. Then these gaseous molecules, they will have some, you can say, energy itself. In the beginning, they themselves will have some energy, but they can't react. Energy barrier will be there. Energy barrier means some energy is required. In a simple way, you can understand that you went to the market. I wanted to purchase a mobile, and mobile cost is 3,000 rupees, and in your pocket only 2,000 is there. You have money, only 2,000. Mobile is of suppose 3,500. Then now you can't purchase the mobile. Then this 3,500, that in a gas it will go just like a curve. From the down it will go up, again from up it will come down, like that way. Then here that difference is there. In your pocket only 2,000 is there, a mobile is of 3,500. Then this difference 1,500 has meaning. 3,500 total cost, that is called threshold energy, THRESH. threshold energy, HOLD. Okay, threshold energy, total energy is just like you consider this cost, you consider as energy. Then 3500, that is the threshold energy, and in your pocket 2000 rupees was there, means this is the energy possessed by the molecules itself. Okay, then what is the difference? Then difference is 1500. Then this is called activation energy, energy of activation. Okay, then gaseous molecules, they have less energy, they can't react. For the reaction, the minimum energy is required, just like your mobile cost 3500, that is the top. Then that's why it is heated. When you will heat, you hit the gas, then they will get the, you can say, energy. They themselves will collide. Collision will be there among themselves, and energy will increase, and it will cross that energy. Means 3500, suppose kilocalorie energy was required. Then either by heating or by collision, if you will heat, then collision will increase. They themselves will collide to each other, and their energy will be more than 3500, and then it will give the product. Okay, then I have sent the diagram. If the last video, you can see that diagram also. Means reactant is giving the product. The direct, it is not giving, you have to heat it. Then that is the, you can say, threshold energy, total energy, it has to cross. Then it will, after the, at this top, at this, when they will, their temperature will be 3500, then what will happen there? N2 and H2, or H2 and I2, any gas you can take as example, their original bond, old bond will begin to break. It will become, you can say, weak bond, very weak. Slowly and slowly, it will, a bond will become loose. Bond will become loose at that temperature, and bond length will increase. Bond length increasing means H2, as for example, bond length will increase. Means bond is becoming weak, and this nitrogen also bond will become weak, and only at that temperature, when bond will become weak, same time new bond it will form. Same times, one time bond will be hydrogen H2 plus I2 example also you can take. Then H bond will become weak, I bond will become weak, and new bond only there at that temperature, HI bond will begin to form. New bond will start forming. Then only there old bond will break, HH bond will break, I bond will break, and HI new bond will form only at the top at 300 degree temperature. That's why it is called transition state. That is also called transition state, means at 350, and after that when they will form HI, 2HI, then their energy it will come down. After forming 2HI, HI molecules energy will come down, and slightly their energy will decrease. And what was the original energy? What they had, sometimes it may come down from that also, less than that energy. Sometimes in case of endothermic reaction, that product energy will be less than reactants. And in case of exothermic reaction, reverse case, that they have more energy. Actually, in the case of reactants, you have to supply the heat. Then reactants have less energy. That's why you have supplied the heat. And product, after forming the product, it was above the reactant energy. But if in the case of exothermic reaction, they have more energy. That's why when they will convert to the product, then it will go down. Heat will go outside. Okay, I will tell you details when I will discuss the chemical kinetics that time. Then here you understood the effect of this thing. Then catalyst I was talking about. Then catalyst, here rate of reaction increases. That time it has a role. by changing their original path. If catalyst is there, then they will follow, you can say, another path which required less heat, less temperature. By changing the, you can say, their path, then catalyst has a role there, not at equilibrium. There is no effect of catalyst on equilibrium. Okay, equilibrium will not disturb the, catalyst will not disturb the equilibrium. Okay, a catalyst increases the rate of the chemical reaction by making available a new low energy pathway for conversion of reactants to products. It increases the rate of forward and reverse reaction. Okay, there also can change reverse also, wherever from product to reactant. That time also, if catalyst you are using, then you can get the reactant quickly, or from the reactant to product also catalyst you are using, then there also you can, it will increase the rate of reaction. It increases the rate of forward and reverse reaction that pass through the same, you can say, transition state, and does not affect equilibrium. Okay, it does not affect equilibrium. Catalyst lower the activation energy for the forward and reverse reaction by exactly the same amount. That's why it has no role. It can't change. Forward direction, forward way, in forward also have same role, and reverse also have same role in the same way. Okay, catalyst lower the activation energy for the forward and reverse reaction by exactly the same amount. Hence, it has no role. It can't disturb the equilibrium. Catalyst does not affect the equilibrium composition of a reaction mixture. It does not appear in the balanced chemical equation or in the equilibrium constant expression. Okay. Then now just a little more I will tell about the these things, ammonia. Then now you can say, here already I told you that here formation of ammonia from nitrogen and hydrogen, which is highly exothermic reaction and proceeds with decrease in total number of moles formed as a compared to the reaction. Equilibrium constant decreases with increase in temperature. Here it has role, already you know, tell you. Equilibrium constant decreases with increase in the temperature. At low temperature, rate decreases and it takes long time to reach at equilibrium, whereas high temperature gives satisfactory rate but poor yields. Then German chemist Haber, I told you, his name was Fritz Haber, discovered that a catalyst consisting of iron catalyst in Haber process it is used. Question is asked. Okay, which catalyst is used? Then iron catalyst is used. Iron catalyst, a catalyst consisting the iron catalyzes the reaction to occur at a satisfactory rate at a temperature where the equilibrium concentration is reasonably favorable. Since the number of moles formed in the reaction is less than those of the reactants, the yield of NH3 can be improved by increasing the pressure. Optimum condition of temperature and pressure of the synthesis of ammonia using catalyst are around 500 degree centigrade. Temperature I told you 500 degree centigrade, and pressure how much? Then 200 atmospheric pressure. Okay, this you keep in mind, 500 degree centigrade and 200 pressure in case of ammonia. In case of sulfuric acid, H2SO4, that is a contact process. Process name is contact process. Then 2SO2 plus O2, 2SO3. And this 2SO3, this SO3 is sulfur trioxide, then you will dissolve in water, then it will form H2SO4. Okay, then this main is the two-way formation of sulfur trioxide gas. 2SO2 plus O2, it is forming 2SO3, and its Kc value is 1.7 into 10 to the power 26, 10 to the power 26. Though the value of K is suggestive of reaction going to completion, but practically the oxidation of SO2 to SO3 is very slow. Actually, Kc value is, it looks K 1.7 into 10 to the power 26, it is more, but actually it goes very slow. Thus, just to increase the rate of the reaction, platinum or vanadium pentaoxide V2O5, divanadium pentaoxide, platinum or vanadium pentaoxide V2O5, anyone is used as catalyst to increase the rate of reaction. Okay, then I have told about the distinct effect of temperature, all the things, effects of temperature, pressure, concentration, means factors affecting the equilibria, all things I have finished. One full question is asked in case of subjective, and for medical engineering that many questions are asked on this. Now I am stopping only here. Next class again we will meet. Thank you.